Okay, so in order for you to hook this up to the Arduino, the first thing you have to do is take it out of this, take this thing out. So I want to put it back in, and I'm going to show you how you can take it out. All you do is you just pull it out. That's it. Just pull it out like that. The next thing you do is you get the pin. Get one of these pins, and you put one of them into here. You unscrew it basically. Okay, to close it, you move it in the clockwise direction, and to open it you just move it in the counterclockwise direction, and as you can see, it's opening up. I put the pin, one of the pins in here like this, and then close it. Don't screw it in too tightly, just tight enough that there's contact between the two. Okay, that's pretty good. And the next one, counterclockwise to open it up. It's opened up. Put it in there and just move it clockwise to close it. It's a little too wide. I'm gonna make it a little bit narrower. I'm going to make sure that's firmly in there. Okay, that's good. And the next thing you do is you hook it up. You put these pins into the Arduino. So one side is positive, the left is positive, and the right is negative. So see how that goes. In relation to this, so that's right is negative, so that goes into the ground. The right pin goes into the ground in the Arduino. I will show you a diagram of this so you can just put it in yourself. Okay, that goes into the ground, and oops, I got it mixed up. I said the right is negative, right? That is right. I'm so confused. Okay, the right. What's the right? It's negative. And the left is positive. So I'm going to put this positive into pin 13. You could put it into any pin you like. The positive is going into a pin from, let's say, 2 to 13, so I'm just going to put it into 13. You could put it into any pin you like. So that's, now that part's hooked up. So you just put it back in here and then just push it in like that, and now it's connected. So the next thing you need is you need to get a power supply for the Arduino if you're going to use this thing to do something, you know, like turning on a light at a specific time, like which I'm going to be doing with this simple project. You just plug this in there, and the next thing is you plug in this cable. The cable that came with it is a bit short, so I'm going to use a longer cable. So I'm going to use this longer cable. So any cable that has a pin layout like this, this is one from one of my computers. They should work from any computer. Okay, that's in, and then you just plug it into the wall. And the way I'm going to be hooking this up in relation to the code that I'm going to be writing is I'm going to plug in my appliance, my lamp here, which is normally off, and that's how I'm going to be using it, because that's how I'm going to write the code. I'm going to put analog write is going to be turning on this pin, is going to be turning on this thing, so it's going to be on first, and then so when I plug in the lamp, it's going to be off. So when I plug in the Arduino and when it runs, it's going to be sending a signal, a 5-volt signal to this relay unit. This is a IOT relay unit. You could use a relay module, but this is a lot simpler to use because you don't have to splice cables and stuff to use it. All you have to do is plug in the pin directly from the relay unit to the Arduino to use it. So I don't have to cut cables, splice cables, and do anything like that, and tie stuff into a relay module. So this is a lot simpler. So that's how I'm going to be doing it. So I'm going to plug it into here, and then, but if you write, and I'm going to be plugging in my Arduino unit, in which you see here is always on. This is always going to be on, so this is what you have to hook up the Arduino unit to right here. Just like that. And that should work. And the next part, I will show you the code. Okay, in this code right here, I basically declared the light an integer, so make sure you get all the caps correctly when you enter this in, but I will leave it in the video descriptions of the code that I used in this example. So I will explain everything right now. So int light equals 13, so that's the pin that I selected, which is going to be turning on. As I put on the comment, pin 13 is declared as the pin I'm going to be using. So you could use any pin you want. You can use pin 10 or pin 4 or whatever you want. But for me, I'm going to be using pin 13. So, and another thing I want to declare is like a constant. So the constant is unsigned long. So I can't use int in this example because I'm going to be turning this thing on for longer than 32 seconds. So the maximum amount of numbers which is allowed with integer or int is 32,768 numbers. So a number cannot be greater than that when you're using integers or int. So I'm going to be using unsigned long, and in order to use an unsigned long, you have to put a UL in the back of the number. So if I had let's say 60 seconds, then it would be 60 seconds times 1000 milliseconds is 60,000 milliseconds. Therefore, it'll be 60,000 capital U and capital L at the back of it. So that's what you have to do. So this Arduino microcontroller is only 16 bits. So when you get 16 bits, you have to add the number 0 also. So you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So adding all those together, you get 16 bits. So we put that in 2 to the exponent of 15. So we get 32,768 as the maximum number we could use for integer. That's why you can't use more than that, more than 32,768 for int. So in practicality, if you want to use int to delay the delay function or the command, you will only be able to get 30 seconds. So that's pretty useless for this project that I'm going to be working on, because I want this light to be turned on like after several hours or something, and that would be 30 seconds would not be enough for that. So next thing, I go to void setup, and I set the pin light. So pin 13 is going to be an output, so that's going to send the 5-volt signal to my IOT relay unit, which will give it a command to turn it on or turn it off or whatever. So next thing, I go to void loop, go to digital write, and you have to watch out for the caps on this too. So digital, capital W, lowercase w, RITE. So light. So pin 13 is on, and the delay it's going to be on for, in this example, 60 seconds. So about 60,000 milliseconds. So if you don't want to use the constants that I declared, you could just simply put 60,000 60000 UL. Is that right? 60000 UL. Okay, on the back, and right where the light on is. And the next thing is digital write. So light is going to be off for 60 seconds, and the delay is light off for 60 seconds. So it'll be 60,000 UL again. So for what I declared on the top, it makes it a lot more simpler, because I could just simply put, if I wanted to do 2 minutes, I could put 2 UL times 60 times 1000. Or if I wanted to put 10 minutes, I could put 10 UL times 60 times 10 minutes. So on the top where you see constant unsigned long light on, if I wanted to leave it on for 20 minutes, I just put 20 in the place of 1 UL, then I could just get it much more easily. So this simple example is going to turn the light on for 60 seconds, and it will turn the light off for 60 seconds, and I'm going to demonstrate that in the next part. I'm going to show you that what I wrote here works. So I'm going to go to now the example of UL. So if you just want to use numbers, so for example, let's say you have 2 minutes, and that would be 120 seconds. So 120 seconds times 1000 milliseconds is 120,000 milliseconds. So in the program, we have to put 120,000 UL as the assigned number in delay. So if we have a larger number like 10 hours, you would have 60 minutes in an hour and 60 seconds in a minute and 1,000 milliseconds in a second. So we can put in the declaration that CONST unsigned capital L lowercase ONG capital N lowercase AME is equal to, let's say, 10 hours, 10 UL times 60 times 60 times 1,000 semicolon delay name. So the name will be for 10 hours. So this would be about, let me calculate how many milliseconds that would be. That would be 36 million UL or milliseconds. So that's how we would use it. Okay, now I'm going to turn on the switch with the code. It's going to be on for 60 seconds and it's going to be off. Okay, now it's off, right? And then it'll be off for 60 seconds and it's going to turn back on for 60 seconds. Okay, now it's on for 60 seconds. Okay, so now that it works, I'm going to turn this off right now. You could make it so that the light switch could turn on, let's say after, the light could be on for, let's say, 10 hours. It could be off for 10 hours in the daytime, and then when you get back home, maybe around like 5 or 6 o'clock, it'll turn back on. So you would leave it on for, let's say, 6 or 7 hours. You could do that as well. So I just want to demonstrate to you that it worked. So in this code, I made all my declarations, except I changed a few things. I'm using 9 hours and 10 hours. So 9 hours on and 10 hours off. Excuse me. So 9 hours, and there's 60 minutes in an hour, and there's 60 seconds in a minute, and there's 1,000 milliseconds in a second. That's how I came out with that number. So 36 million milliseconds for 10 hours. So again, I made my I put pin mode for light, output for in the void setup, and I assigned unsigned logs for hours on and off, and that's what's going to be displayed basically.